これね、ローランドのジュノー106って
ストリングスやオルガンサウンドをはじめ128種類のオリジナルサウンドがメモリーできるんだ。
スピーカーがついてるわ。
うん、スイッチオンですぐ演奏できるってわけ。
Yeah, I know, that's the wrong Juno, but an evolution of sorts. No fake wood grain, a lot more plastic and built-in speakers. Anyway, I couldn't find any cheesy adverts of the actual Juno in question, so yeah, we'll run with that. This is a Juno 60. It was released in the early 80s, shortly after the Juno 6, to which it is very similar but has a few additional features. Most significantly, preset memory, which allows patches to be stored and recalled. Pretty handy. It's a polysynth with 6 notes of polyphony, meaning it can play 6 notes at the same time, opposed to a monophonic synth. The Juno series was intended as a more affordable option to Roland's range of polyphonic keyboards such as the Jupiter 8, and it achieves this through a few cost-saving measures. For example, it has a single oscillator per voice. The Jupiter 8, on the other hand, has an 8-note polyphony and uses 2 oscillators per voice. Therefore, the Juno 6 has a lot less oscillators, it doesn't layer up sounds, and the downside of this is that the sound can be a bit kind of thinner. However, the Juno uses a few tricks to get around this, such as using a sub-oscillator voice, which uses a simple frequency divider circuit, like a flip-flop, which adds in a lower octave, and of course the famous chorus circuit, which creates a rich and wide sound, which, yeah, may be somewhat similar to stacking mixing oscillators. I love the design and the look of the Juno. It's simple, clean and intuitive. There's a nice flow to how you might start and finish creating a patch. Today, this may be thought of as good user experience, and this was part of the appeal, making it accessible and easy to understand for musicians not so familiar with synthesizers. Adding patch memory to an analog synthesizer adds a fair amount of complexity to its design, and for a long time was kind of a big challenge, electronically speaking that is. For example, on the Juno 6, many of these buttons and sliders are actually directly in circuit with the elements they control, such as the filter. On the Juno 60, everything is more like a remote control. The position of a slider is sampled, stored as a value in memory, and then relayed to an electronically controlled counterpart. Around the back there are ports to hook up a tape machine for saving and loading patch memory. There is also a DCB port, Roland's proprietary control system for hooking the synth up to a sequencer. Sort of like an early form of MIDI. Right, this Juno is not without its issues. I don't think it's anything serious, but some of the buttons don't really work, mainly for the patch memory, and I think it just needs some contact cleaner, and that should sort that all out. The arpeggiator doesn't really work either, it just makes a horrible noise really. So let's dive into it. I've unscrewed both PCBs from the top of the case and laid them out on these T-tiles to keep it all nice and safe. As both boards are connected, it just makes it easier to work on. Also, we need to look at the arpeggiator clock circuit, which is on the other PCB. I've also raised up the Juno on this base head, which allows for the top of the case to fully open backwards. Just going to work on the affected buttons. The top of the caps just pull off, and then underneath there's a little silicone membrane type push button which you can gently lift out with some tweezers. You can clean the contacts on the board with a cotton bud and some contact cleaner, but you do not want to get this on the silicone part. It will expand and you will most likely damage this hard to find part trying to fit it back in. To clean the silicone part, use isopropyl alcohol, IPA, to which I don't have any right now, but I do have one of these disinfectant wipes, which is pretty much the same stuff. Once that's all done, put it back together. Great, all the affected buttons now work perfectly. Next up, let's take a look at the ARP circuit. I'm pretty sure it's just the mechanical part, the slider, but there's a few other things that we can take a look at. I'll hit it with some contact cleaner first and we'll try it out. Baby. That didn't seem to work, so let's check resistance across the slider. Resistance seems okay, or at least it should in theory work okay, if not entirely smooth. Looking at the schematic, the only thing really that could go wrong is this op-amp, so I can try replacing it. The op-amp used is actually a dual package, i.e. there's two op-amps in this single IC, and only one of them is in use, the other one's not even in circuit with anything. Also looks like the package has a symmetrical pin layout, so I should be able to desolder it and flip it around, stick it back in. Hopefully the unused op-amp will fix it. There we go. No such luck. Maybe a slight difference. I've also checked out the two transistors and the diode in the ARP clock circuit with a meter, but I'm not finding any shorts. Voltages to the op-amp all seem okay, so I'm back to suspecting the slider, which I will now order along with the broken pitch bender. And yeah, let's see how we go with that. Solder sucker, arpeggio rate slider coming out. So I don't really advocate using these things because they have a habit of pulling the tracks off or the traces off the PCB if you're not careful. Solder wick and lots of flux is generally a better way to go. And I suppose the trick is to try not to apply too much heat. Hey, straight out. Nice. Right, we'll test this. Feels good. First, let's check that they are kind of the same. Yeah, they look pretty identical to me. Cool. I didn't really explain how the arpeggiator works on the Juno. There are basically two parts to it, the key assigner and the clock. The key assigner basically deals with the fact that the Juno doesn't have an oscillator for every key on the keyboard. It can only play 6 notes at one given time. So the key assigner scans the keyboard for notes being played and then assigns the notes to available oscillators. Once the maximum number of oscillators or polyphony has been reached, in order for a new note to sound, it must cancel one of those notes to play a new one. And there are a number of ways it prioritizes which notes are to be played, and that's known as note priority. So when the arpeggiator is active, the key assigner will sequence the notes in a chord and play them in steps. It has a few modes to go from the lowest note to the highest, or the other way around, or up and down, and you can also expand this over a number of octaves. And it will use the arpeggiator clock, which generates just a series of pulses, to determine the speed or the tempo of that pattern. Somehow, when I first looked at the schematic for the ARP clock, I missed this capacitor that's in the circuit. This, with the slider, the potentiometer, forms an RC network and determines the frequency the op-amp will oscillate at. So, pretty obvious thing to check, really. Look, Mum, no computer here. I've made an LFO on a breadboard to control the arpeggiation on my Juno 6D. Okay, so I've recreated the LFO circuit that's actually in the Roland here, out here on a breadboard. It's using a different op amp, but they more or less do the same kind of thing. And the idea behind this is I can kind of mess around with this circuit and try and recreate the same fault that's happening in the Juno 60 and hear it out here on the bench. So yeah, just to explain, this is just sending a square wave, a little pulse output, down this jack cable into the arpeggiator clock in. And I can adjust the speed on this potentiometer here. I can obviously hear that coming out the headphones there. So I can plug the headphones directly into this and you can hear essentially what's going to the Juno. Okay, so now we've got the headphones directly plugged in. And that's the pulse being sent out of this LFO circuit. And I've got a multimeter set to frequency here. So you can see it goes all the way up to 22 Hertz or 22 times a second. All the way down to about 0.8 Hertz. Right, let's see what happens if we put a much lower value capacitor in circuit. Drop this one in. This is probably going to make some audio frequency type shit now. Oh, isn't that a nice sound? Yeah, you can see it's gone mental. It sounds crazy. Just like the circuit on the Juno does. Which I can demonstrate again. Let's go and have a look. Let's unplug that. Now this is the Juno's arpeggiator. It's a mess. Okay, not sure how I missed this, but there's a capacitor in this LFO circuit, which, if its values drifted, it's definitely the kind of thing that would cause the problems that we're hearing. So let's try and replace it and see what happens. So that should get it out. It actually looks pretty crusty on the bottom. There we go. Kind of looks a bit shitty. Let's chuck another one in, see what happens. And we're in. Okay, so moment of truth. Did replacing that capacitor sort out the problem? Arpeggiator is on. And it sounds promising, sounds good. Hit the hold. Yeah, it sounds like it's done the job. Sick. Okay, so if that capacitor has gone bad, it may pay to do the due diligence and replace these big boys in the power supply, because if they're going bad, then it could ruin the transformer here, and the repair starts to get a little more expensive. Now I'm going to change the capacitors in the power supply. I just need to unscrew the PCB from the base, and also these little regulators on the back that hold to the heatsink. This heatsink goes all the way underneath the board, so to get to the underside of the board I have to disconnect it from that. Right, so I've removed the 5 screws from the base PCB, and then these linear regulators that are attached to the back of the heatsink. There's a little bolt and washer on the other side of that, so be careful when taking those out. I've also just taken off a little cable tie here to make this easier to pull forward. So now I've got access to the underside of this. I can remove the solder and put the new capacitors in. There we go. Pull them out. Right, let's put the capacitors in. Get the polarity right. So the negative is marked on this side of the body and has the shorter lead, and it goes to the white marking on the PCB. Slot these in. Cool. Let's solder those up on a stick. There we go. Cool. All looks good. So there we are. Everybody's reinstalled. Final thing I'm going to do on this is to replace the pitch bender. I've got a new one here. This module on the end, it's just held in with 4 screws, I think, underneath, and then it just lifts up. I've got access to it here. These 2 screws on the top to get that out, like so. Spring off. Done. Yeah, and sort of beyond doing that, the only thing really left to do is just give it a bit of a clean. Some of these circuit boards have got what looks like a bit of corrosion. Yeah, just wipe that off with a bit of IPA and an old toothbrush, something like that. Okay, so there's like a couple of kind of hidden features on the Juno 60. You can access extra patch memories, and you can do this by pressing down number 5 and then 1 or 2 at the same time, and you get access to patches 57 through to 76. And then you can access the test programs, basically patches 80 to 98, and to do that you need to stick a jack in the patch shift connector on the back. Then whilst you're holding down 5 and press 3, that gives you access to bank 8, and if you press 5 and 4 for bank 9, so that's like banks 80 and banks 90. And then there's another one where you can change the way the Juno does its key assignment. There's 3 different modes for the key assignment, as detailed in the service notes. To enter the test mode, hold the key transpose button down, turn the power on, and continue holding the key transpose button for 2 seconds. The 3 key assign modes can now be selected through the arpeggiator mode selector. With the arpeggiator selector in the up position, all 6 voices are assigned to the same key simultaneously, so you get like a stacked oscillator sound. Up and down for rotary mode, the CPU assigns channels in cyclic order to the keys being played and remembers the last channel even after the key is released. New assignment will start with the next channel. Note that the first key does not always activate channel 1. Okay, and then with the switch in the down position, if a second key is pressed, one key is pressed. The down position non-rotary, if a second key is pressed whilst one key is pressed, channel 2 is activated. If any preceding keys are open, yeah, if that makes any sense to anybody. I'm just reading this off of the service manual, but yeah, maybe we'll just power it on and give those a go and see what it actually does. You can hear the difference when we put it into unison mode. And then let's try and figure out these other modes then. So in the up-down position, a sustaining patch. Okay, so I think that's the standard mode. And then the down position. Yeah, okay, so that's low priority mode, meaning that the lower keys always stay pressed and it's the last high key that gets cancelled, or the first of the last high keys, something like that. The low keys stay active. So that's that. Okay, let's try and access some of these hidden patches. You need to press down 5 and 1 or 2 at the same time. Well, it actually kind of says it on the front panel. That's pretty cool. Classic drop a bomb. Okay. Okay, so 5 and 7. Helicopter. Disco Toms. Interesting. appears to be noise. Or hi-hat. Sounds familiar. Ocean wave. Splash. There's that wind through the trees. Nice. Stick a cable in the patch shift. Bam. Hold down 5, press 3. 81. No idea what that does. That's a bit louder. Nothing. Okay. Appears to be a test tone that's the same on every key. There's a slight. What does 84 do? 85. Okay. 86. Right, 5 and 4. Ooh. That's nice. Could do that all day. No. I think this is my favourite test program. Yeah, all these programs are for sort of calibrating the electronics in the Juno to get it all functioning correctly. I think a couple of them sort of do a sort of a memory test to scan for any bad bits of memory. But yeah, that's it. The not so hidden bonus features of the Roland Juno 60. The Juno 60 doesn't come with MIDI, but it is possible to retrofit this with a kit. Let me know down in the comments if you'd like to see that in a future video. Thanks for watching. Please leave a thumbs up if you enjoyed this, found it useful, or even consider subscribing. That would be great. Cheers.